really well. So let's try this first example. We want to evaluate the integral of x cubed over square root of 9 plus x squared. Hopefully you can see that 9 is 3 squared. So let's start with x. So we want to let x to be 3 tangent theta, where theta is in between negative pi over 2 and pi over 2. Then dx should be 3 secant squared theta. So now let's try to rewrite. Square root of 9 plus x squared turn into 9. Square root of 9 plus 9 tangent squared of x. And then we want to factor out the 9. So we ended up with 1 plus tangent squared of x. But 1 plus tangent squared is a trig identity. That's just secant squared. So when you take the square root, we ended up with 3 absolute values of secant theta. I want to make sure I change it into theta. So what we have is 3 secant theta. Now, go back to our integral. We have x cubed over square root 9 plus x squared dx. Using the substitution, we have 3 cubed, which is 27, tangent cube theta over 3 secant theta. Now, what we have is 3 secant square theta d theta. That's the dx right here. Let's simplify it. So we ended up with 27. Don't forget that I have 3 here and 3 here, so that just cancel out. Let's take the 27 out. So we have what inside, and then we cancel out 1 secant. So inside, we have tangent cube theta secant theta d theta. I'm going to rewrite and make tangent cube into tangent square theta and tangent theta. So you can see that tangent square theta, we can use the identity, which is secant square theta minus 1. And this tangent theta, secant theta is going to be really nice because that's going to be the derivative when you use u substitution. So I'm going to put the u substitution right here. Let u to be secant theta. Therefore, du is going to be secant theta, tangent theta. Now, going back to our problems, we have 27. And now, that tangent square turned into a secant square minus 1. Tangent theta, secant theta, d theta. Using u substitution, I have 27 u squared minus 1 du. This whole thing is du. So now we just integrate. I have 27 1/3 u cubed minus u plus c, which is 9 secant cubed theta minus 27 secant theta plus c. All right, let's take care of the right triangle. So what I have, don't forget from the beginning we let x to be 3 tangent theta. So let's rewrite that. X equals to 3 tangent theta. So tangent theta is x over 3. And don't forget tangent is opposite over adjacent. So let's draw the triangle. So what I have, the right triangle. So we have opposite over adjacent. So we need the hypotenuse. So hypotenuse, we're using Pythagorean theorems. We have x squared plus 3 squared is going to be the hypotenuse right here. And then I take the square root. So it's going to be x squared plus 9. Now, going back here, I have 9. Secant is going to be hypotenuse over adjacent. So I have square root x squared plus 9 over 3 cubed minus 27 x squared plus 9 over 3 plus c. Let's simplify it. So right here we have 3 cubed, so that's 27 with that 9. 9 over 27, we reduce it, turn into a 1/3. And I have x squared plus 9, 3 over 2. Minus 27 divided by 3 is 9. Square root of x squared plus 9 plus c. And that's the final answer. I want to try this problem. So hopefully you can see that this part right here resemble the sign. So we're gonna let x to be 6 sine theta. Therefore, dx is gonna be 6 cosine theta d theta. Now, when x equal to 0, theta is gonna be 0. When x equals to 3, theta is gonna be pi over 6. So now, instead of writing 0 to 3x over square root of 36 minus x squared dx, we're going to try the trig substitution from 0 to pi over 6. So x turned into 6 sine theta over square root 36 1 minus sine square theta. Dx turned into 6 cosine theta d theta. So now we should do we should simplify it. So what I have here, on top, we have 6 sine theta. On the bottom, as you can see right here, 1 minus sine squared is going to be cosine squared. And then when you take the square root, we ended up with 6 cosine theta. And I have 6 cosine theta d theta. So what we have, you can take out the 6. So we're going to have 6 from 0 to pi over 6 sine theta d theta. And when we integrate that, it's turned into a 6 negative cosine theta. And we want to evaluate from 0 to pi over 6. So what I have, negative cosine of pi over 6 turned into negative square root of 3 over 2. And then when you put negative cosine theta of 0, you get negative 1. So it turns into a positive 1 right there. So when I simplify it, when I distribute, I ended up with 6 minus 3 rad 3. And let's just leave our answer like that. However, so from the beginning, hopefully you can see right away, we can use u substitution. See right here, if I let u to be x squared, du turn into a negative 2x, and we have that x here. So u substitution is actually easier. So if we use a different method, and we let u to be 36 minus x squared, du is going to be negative 2x dx. Then once again, x equal to 0, u is going to be 36. X equals 3, u is going to be 27. So when I plug it in, 36 minus x squared dx is going to be from 36 to 27, 1 over square root of u. And then we have negative 1/2 du because of this negative 2 over here. So when we simplify it and we integrate, we can definitely take the negative 1/2 out. And when I integrate, I ended up with 2 square root of u. From 36 to 27. Evaluate, I ended up with square root of 27 minus square root of 36, which is 6 minus 3 radical 3. Exactly the same, and it's so much easier. The next problem is not so obvious because of this. As you can see right here, we don't have the perfect square, so we're going to have to complete the square to make it into a perfect square. So when I complete the square, I'm going to have to add a number. So that number is going to be b divided by 2 squared. So in this case, it's going to be 2 divided by 2 is 1. Square is going to be 1. So I'm adding 1. Now you cannot just simply add 1 because you're going to change the problem. So if I add 1, I have to subtract 1 right away. And don't forget, we still have that plus 5 there. So this part turned into an x plus 1 squared, which is a perfect binomial. And negative 1 plus 5 is going to be plus 4. So now what I have, Instead of writing x squared plus 2x plus 5, I'm going to write square root x plus 1 squared plus 4. So we're gonna do the trig substitution now. We're gonna let x plus 1 to be 2 tangent theta. Therefore, dx is going to be 2 secant square theta d theta. So now what we have is 2 dx is 2 secant square theta d theta. And on the bottom, we have 2 secant theta. So that's just secant theta d theta, which is ln, the absolute values of secant theta plus tangent theta plus C1. The reason I have to put C1 because we're going to have to rewrite and plug it back in for x plus 1. You can see right here, we have x plus 1 equals to 2 tangent theta. Therefore, tangent theta is x plus 1 over 2. So we have x plus 1 over here. That's the opposite. 2 is adjacent. And we have x squared plus 2x plus 5 for the hypotenuse. So secant is going to be the hypotenuse over adjacent. So I have ln of square root of x squared plus 2x plus 5 over 2 plus tangent is going to be opposite over adjacent. So it's going to be x plus 1 over 2 plus c1. So you see right here, we can get rid of this 2. Okay? So this is ln of that whole thing divided by 2. So using the log property, I can just subtract, because when you divide, you subtract the log function. So we can turn it into ln x squared plus 2x plus 5 plus x plus 1 plus c. And this c is going to be c1 minus ln 2. And that's the final answer.